Hello everyone, today I will show you how to solve systems of equations and inequalities. You have seen this before, but most likely you've seen this only with linear equations and inequalities. But today we'll also include some non-linear things, meaning you may see squares, square roots, and so on inside of your either equations or inequalities. So we will start by solving these two systems of inequalities. Systems of inequalities can only be solved graphically. And then I will show you how to solve this system of equations, first graphically, but then we'll also solve it algebraically. To solve a system of inequalities, and normally a system would be written with inequalities one under another. I just ran out of space, so I wrote the first one here, second, third, and then fourth one here. There is 4 inequalities in this system. So to graph it, we're going to make each one of these inequalities into an equation. So we'll have x plus 3y equals 9. And then we're going to have y equals 9 minus 3x, this one right here. And then this one will become x equals 0, and this one will become y equals 0. Well, let's first graph x plus 3y equals 9. I'm going to graph it in pink. This is the standard form of a line equation. That's most of the time is possible to graph using intercepts. To find these intercepts, x-intercept and y-intercept, you make the other variable a 0. So you first make x a 0, pretend that x is 0. You're left with 3y equals 9, which means y equals 3. That's your y-intercept. You place that on y-axis. The next step is to make your y a 0. So this term turns into 0, and you're left with x equals 9. That's your x-intercept. 7, 8, 9. And then you're going to connect these points to graph the line. This line will be solid because the original inequality has symbol less than or equal to. If it was less than without equal to, the line would need to be dashed. Well, here is the line that we created by graphing the equation x plus 3y equals 9. Remember, this was an equation that we made out of the first inequality. Simply change the inequality symbol into the equation symbol, the equal to sign. Now we need to determine which side of this line, either below it or above it, will be the side that satisfies our inequality. To check if it's this side below the line or this side above the line, we need to pick a point on one of the sides. I'm going to pick a point with coordinates 0, 0 right here. In this point is located below the line, so that's the side of the line we're checking. I'm going to replace my x inside of the inequality with the first 0 from the point, and my y inside of the inequality with the second 0 from the point. So this inequality will turn into 0 is less than or equal to 9. So 0 is less than or equal to 9. The question you need to ask yourself is if it's true or if it's not. So is 0 really less than or equal to 9? Yes, 0 is less than 9. So the point that we picked, which is below the line, produced the true inequality for us. So that's the side of the line that we're going to shade. So now we're going to graph the second line, which is y equals 9 minus 3x. Remember, this equation was produced by the second inequality. We simply changed the less than or equal to into equal to sign. So this is a slope-intercept equation of a line. I will start by graphing it on 9 on y-axis, and then I'm going to go down 3 units and over 1 unit to the right, because the slope is negative 3 over 1. So start on 9, 7, 8, 9. Go down 3 and to the right 1. Then I will be connecting these 2 points with a solid line. The line will be solid because the symbol of the inequality is less than or equal to. If it was less than, the line would be dashed. Well, here is the line, and we now need to decide which side of that line we will shade. Pretending that the original shading for the pink line is not here, we will treat this as a completely separate problem. The blue line splits our coordinate plane into the left side and the right side. We need to decide which side of it to shade. So I'm going to pick a point on the left side of the blue line, and that point will again be 0, 0. And I will use this 0 to replace x in my inequality for the second line, and this 0 to replace y in this inequality. So y turns into 0, x turns into 0, which means my inequality is now 0 is less than or equal to 9. 0 is less than or equal to 9. Is this true? Yes. So the side of the line where that point was is the true side, and that's the side we're going to shade. Remember the side of the blue line now. So far, the shadings of the purple line and the blue line intercepted in this corner here. If you notice, you have both shadings right here in this corner. Now we have two more lines to grab. The next line will be x equals 0. X equals 0 is nothing but a vertical line that passes through 0 on x-axis. The line will be solid because the original inequality had a greater than or equal to sign. The line that passes through 0 on x-axis and is vertical is y-axis. Well, here is the green line, x equals 0. We need to decide which side of the green line to shade, left side or right side. We will need to pick a point that's not on the line, either on the left side or on the right side of our line. I'm going to pick a point with coordinates, let's say 5, 4, 5, 4. This point is to the right of our green line, and that's the side of the line we will be checking. In this ordered pair, 5 is x and 4 is y. We will be replacing x with 5 and y with 4 in our original inequality for the green line. The original inequality was x is greater than or equal to 0, so we will replace this x with 5. There is no y to replace, so you just ignore the 4. So replacing x with 5 gives us 5 is greater than or equal to 0. Is this true? Yes. So we will be shading the side of the line where the point was, which means the right side of the line. So far, the three shadings for the purple line, blue line, and green line intercepted in this part of the coordinate plane right here. All three shadings are present in this part. So we have one final line to graph, and that's y equals 0. It's a horizontal line that passes through 0 on y-axis. So that's going to be our x-axis, and I'm going to graph that. Here's the bright blue line I graphed, y equals 0. We need to decide which side of this line to shade. To do that, I will pick a point that's not on the line. So let's say I'll pick this point. This point is below the blue line, and it has coordinates -3, -3. This -3 represents the x, this -3 represents the y. So I will be replacing x and y with these numbers in the original inequality. My original inequality was y is greater than or equal to 0. So y is now -3 from this point. So -3 is greater than or equal to 0. Is this true? No, it's false. So the point was below the blue line, and it gave me a false statement. So what that means is I need to shade the other side of the blue line, so it's above. The question, after you finally shaded all of the sides of all of the lines, is where do all of these shadings intercept? All of them intercept forming this shape right here. This shape is the solution to the system of these four inequalities. So the first step is to change this inequality into an equation, which I did right here. This is nothing but a parabola that starts 5 units below 0 because it went 5 units down from its original vertex. So the new vertex is 0, -5, and you just draw a parabola that opens up. This parabola will be solid because the symbol is greater than or equal to. If the symbol was greater than without equal to, you would dash the parabola, but my parabola is solid. We now need to decide which side of the parabola to shade. The parabola splits our coordinate plane into two sides, so to speak. One is inside of the parabola and one is outside of the parabola. To decide which side of the parabola to shade, I will pick a point. The easy point to pick is, again, the origin. It's inside of the parabola, so that's the side we will be checking. To check if this side is a true side, I will insert 0 for x and 0 for y inside of the original inequality. So this here turns into 0 is greater than or equal to 0 squared minus 5, so -5. Is 0 greater than -5? Well, yes, 0 is greater than any negative number. So the inside of the parabola is the true side, and that's where I'm going to shade. Now I will graph the second inequality. To graph the second inequality, I have to make it into an equation. Y equals 2x. This is a linear equation, and the graph of it is line that has the y-intercept of 0 and a slope of 2 over 1. So my first point is 0, and from there I'm going to go up 2 and to the right 1. When I connect these 2 points, I will have a solid line because the inequality suggests less than or equal to and not strictly less than. So here is the line, and this line splits our coordinate plane into 2 sides, the left side and the right side, and I need to check which side is true. To check which side is true, I'll pick a point. I cannot pick 0, 0 because the line passes through 0, 0. I have to pick something that's on one of the sides. So how about we pick this point that has coordinates 5, 2. That means we're checking the right side of the pink line. So if I replace x with 5 from the point and y with 2 from the point, I will have 2 is less than or equal to 2 times 5. So 2 is less than or equal to 10. Is it true? Yes, 2 is less than 10. So we're going to shade the side where the point was, which is the right side of our line. The solution to the system is where 2 shadings intersect, which is this part of the graph right here. Now we will be solving the system of equations graphically. You are given 2 equations. The second one here, x plus y equals 3, is a linear equation and it's a line. So here is, I changed this a little bit here, it's a 25 now. So the first graph, the graph that I already have here is the graph of this line. It's a standard equation of a line, x plus y equals 3. I graphed it using intercepts. I found the x-intercept by plugging 0 into y and found y-intercept by plugging 0 into x. And both of the intercepts turned out to be 3. And then I graphed the line. So the first equation here is the equation of a circle. Remember that the general form is x minus h squared plus y minus k squared equals r squared. So h and k are the coordinates of the center, and there's 0 in my equation. So the center of the circle will be at the origin. Now the radius squared in my equation is 25, so the actual radius is 5. So I'm going to count 5 units up, 5 units to the right, 5 units down, and 5 units to the left. And then connect them. The solution to the system is where the 2 shapes intersect. Specifically, we'll have two of those here, two of those points of intersection. One is here and one is here. So the coordinates of this one, and of course they're not precise because I didn't use the software to graph this, but the coordinates of this one approximately 4.5 and -2. So we're just going to do maybe 5, -2. 5, -2 is the first solution, and then 5 over -2, and then this one here is -2, 5. So I'm going to take the y to the other side, and that will give me x equals 3 minus y. What I will do next is I will replace x inside of the first equation with 3 minus y. So this will now become 3 minus y squared, because the first equation tells me to take x and square it, plus y squared equals 25. I want to FOIL this because 3 minus y squared is 3 minus y times 3 minus y. FOILing it gives you 9 minus 6y plus y squared. So this is this set of parentheses, which means this first equation now is 9 minus 6y plus y squared plus another y squared equals 25. I'm going to combine like terms. So y squared and y squared, those will give me 2y squared, and then minus 6y. And I have this 9 equals 25. This is a quadratic equation, so to solve it, I'm going to move all terms to the left side. 25 will go to the left and will get subtracted from this 9, so that I have a 0 on the right. Okay. So all of these terms are divisible by 2. So I'm going to go ahead and divide all of the terms by 2. So I will have y squared divided by 2 minus 3y minus 8 equals 0. And I'm going to solve using the quadratic formula. I'm going to say y equals, for the quadratic formula, since the equation is in terms of y, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, well, let's simplify this. So this is negative b plus or minus the square root of 9 plus 32 all over 2. 9 plus 32 is 41. So I have 3 plus or minus the square root of 41 all over 2. If you can simplify the square root, definitely do it, but 41 is prime. You can't break it down. So the two answers that we got for our y are 3 plus square root of 41 over 2. That's the first y. And y is also 3 minus the square root of 41 over 2. These are the two solutions. Now remember, this is the same system that we graphed before. Remember, when I solved this graphically, I got 5, -2 as my solutions and -5, but that was very approximate. Let's plug these into the calculator and see if they match the solution we obtained from the graph. Three plus the square root of 41 divided by 2 is approximately 4.7, which is close to 5 that I got from the graph. The second answer is 3 minus the square root of 41 all divided by 2 that I got from solving equation algebraically is -1.7, which is close to -2 I got from the graph. Okay, so these are my y's. Now the solution to a system is the x and the y both. So I'm going to now find the x. Based on the system, x was equal to 3 minus y. So I just have to subtract these solutions from 3, and that will be x.